Hello, my name is Jared and welcome to the Synthetic Math series. This is part one. We're going to look at the concepts. In part two, we'll look at synthetic division. And in part three, we'll look at synthetic square roots. So what is synthetic math? Most people think of synthetic division if they've ever heard of it, but most people probably have not heard of synthetic math. So what is it? Synthetic math is, in a nutshell, using a basic math platform, but following algebraic rules. So what does that mean? Well, in basic math, there is a certain simplicity because we don't write the base and the exponent. And we'll look at that a little bit later. Also, in basic math, there is a strict organization because we don't write the base and the exponent. And so the organizational structure is really tight. So that part we take from basic math, but we keep the algebraic flexibility, meaning we're allowed double digits or multi-digits for a particular place value. We're allowed negative digits. We're allowed fractions. So when you take the best of both worlds, that's basically what you get with synthetic math. Second of all, why do synthetic math? Well, the reason why most people do synthetic math is for time efficiency. And you're going to see that especially in part two with the synthetic division. But here in part one, because we're looking at the concepts, we're not particularly worried about time efficiency right now. The second reason why you'd want to do synthetic math is for conceptual understanding. Once you get involved with synthetic math, kind of opens up your understanding of a lot more of the connections or differences between basic math and algebra. How do you do synthetic math? Well, basically just need to give you three concept lessons. The first one is on place value, to look at those differences between basic math and algebra. Second is the platform itself, which means your operational format. So in this video, we're going to do add, subtract, and multiply. And number three, the third concept is the procedure itself, or how the execution concepts that are there for the particular operation that we're doing. This is going to be important in synthetic division because synthetic division is not actually based on the basic math format. It's a different one. So you need to understand those concepts so you can make that transition. Okay, so we're going to start with the place value and understanding of that. So for place value, consider the number 274. When you read it, you don't say 274, you automatically input its place value. You say 274. Why do we do that? Well, we know that the 4 is in the ones column. We know that the 7 is in the tens column. We know that the 2 is in the hundreds column. So it's organized by place value, and so we automatically read that. What we don't see, and this is the simplicity part, is we don't see the base and the exponent. In other words, we don't write this as 2 times 10 squared plus 7 times 10 to the first plus 4 times 10 to the 0. So since we don't write the base and the exponent, it makes it a little more simpler form. But the organization is what informs us of its place value. Whereas in algebra, if you look at the same numbers, 2, 7, and 4, assuming for our illustration that x is a 10, this would be 2 times 10 squared, that's our 200, plus 7 times 10, that's our 70, plus 4. This would still be 274. So it makes algebra a little bit more cumbersome, is we're always writing the variable and the exponent. Now, on the other hand, algebra has a little bit of flexibility. Because we write the variable and exponent, we can actually write it in any order that we want. Usually we prefer the descending exponential order, but it can actually be written any way and it's still the same value. We cannot do that in basic math. We cannot switch the order around. So there is some flexibility in algebra. There's some organization and simplicity in basic math. That is what we want to combine together in synthetic math. Take another example here, the number 301. Notice the 0 is a placeholder because there are no tens. We can't just skip it. We can't say 31 or 301. We have to have that 0 as the placeholder so that people know there are no tens. However, in algebra, we don't use 0 for placeholders. 0 times anything cancels out. We just put 3x squared plus 1. So if we're going to use the basic math format, we need to be putting in zeros for our algebraic part. We need to have this as a 0x plus 1. So we need to remember to keep zeros as a placeholder. Take, for example, the number 75. Here's another illustration. In basic math, 75 is the only way that you can say 75. And that's because in basic math, you're only allowed single digits. You're not allowed double digits. You're not allowed negative digits. So you have to build up to the number. You have 7 tens, 5 ones. That's it. Whereas in algebra, there's a lot more flexibility and a lot more ways that you can represent 75. Again, if our x represents 10, the most obvious expression would be 7 times 10 is 70 plus 5. So our 7x plus 5 could represent 75. But we're not limited to just building up. Because we're allowed double digit and negative numbers, we can also build down. So in other words, we can go past 75 with 100, that is 1 times 10 squared, 100, then subtract 30, 100 minus 30, that's 70, then plus 5. So this also would represent 75. Here we have 5 times 10, that's 50, plus 25 is also 75. So there's a lot more flexibility here, different ways of expressing the same value. And that's because, again, the double digits and the positives or negatives, even fractions are allowed in algebra to represent a place value where they are not allowed in basic math. So this is some conceptual understanding of place value. Next, we're going to look at the platforms of addition, subtraction, and multiplication, where you can really see the difference between a conventional approach and an unconventional approach and how it applies to algebra, which we call then the synthetic math. Okay, let's first look at the platform of addition. In addition, we line up numbers based on their place value. So if we're going to add 38 plus 25, we see that we line up the ones column, we line up the tens column. When we add in basic math, we have 8 plus 5. Well, that's actually 13. So instead of putting 13 here, because we're only allowed 1 digit in a placeholder so that we don't get confused when we're looking at the entire number. So 13, we know it's base 10. So once we reach 10, we transfer 10 ones and it becomes 110. So we put a 10 of those ones as 110 in the tens column. Then we add that up and we get 63. Now, if we do the same thing in algebra, 3x plus 8, 2x plus 5, again, allowing x to represent 10, we're allowed, it's more flexible in the sense that we're allowed double digit numbers. So this just becomes plus 13, this becomes 5x. But notice that we are writing now the variable and the exponent, which when you have larger polynomials, you're constantly writing x and some exponent attached to it. So what synthetic math is taking the basic math platform, but following the algebraic rules. So we go 8 and 5 is 13, 3 and 2 is 5, and you say, well, how is that the same as 63? Well, we have 5 tens, so that's a 50, and 13 ones, and so that adds up to 63. Okay, so it's the same value. And then we can just go back here and in our final part, we can put the variables and the exponents back in the final answer, but we don't have to all the way through the working of it. So if we do the same thing with subtraction, Here we have 75 minus 28. If in basic math, we have to borrow if there's not enough ones. 5 minus 8, there's not enough. We're not allowed negative digits. So we borrow from the tens column. So if we take one of those tens, that reduces us to 6. 110 becomes 10 ones. So now we have 15 over here. 15 minus 8 is 7. 6 minus 2 is 4. We get 47. In algebra, we are allowed negatives. So 5 minus 8 is negative 3. 7 minus 2 is 5x. Again, we have to write all those variables and exponents out. Again, you need to, imagine larger polynomials. So if we use synthetic math, here's synthetic addition, here's synthetic subtraction. We're just taking the coefficients of our polynomials. We are placing it in the platform of a basic math operation, but we follow algebraic rules. So 5 minus 8 is negative 3, 7 minus 2 is 5. Is that the same? Well, you have 5 tens, that's 50. You subtract 3 ones, you get 47. It's actually the same value. And we can just go back here, and in our answer, we can supply the variable and exponent. Because in algebra, we actually don't know what the base is, which is why we can't carry and borrow in algebra, because we don't know the value of the base. But for illustration purposes, we're just assuming it's a base 10, so that we can show you that it does actually have the same value as basic math, but the form looks a little bit different, 5x minus 3. Okay, now we're going to look at multiplication. Okay, for the multiplication platform, again, we just set it up again by place value. And now we're going to multiply. So 5 times 7 is 35. We carry the 3. 3 times 7 is 21. 22 to 3, 24. Put a 0. 2 times 5 is 10. Carry the 1. 2 times 3 is 6 plus 1 is 7. So we get 945. If we do the same thing in algebra, remember we're allowed multiple digits. 5 times 7 is 35. 3x times 7 is 21x. We have our 0. 2x times 5 is 10x. 2x times 3, there's our 6x squared. So we get 6x squared plus 31x plus 35. So notice we're writing all of those variables and exponents. So if we do the synthetic multiplication, again, we're using the basic math platform. We just copy the coefficients from our polynomial, but we follow the algebraic rules. 5 times 7 is 35, 3 times 7 is 21, 10 and 6, 6, 31, 35. Very fast and easy to do. Is this the same value as this? Of course it is. You have 6 in the x squared column. That's like your hundreds column. So 600. 31 in the tens column. That's 310. That gives us 910 plus 35 ones. Gives us 945, the same thing that we got over here. So again, using the basic math platform, algebraic rules, you can go back and put your variables and exponents in your final answer, but your working is a little bit more smooth and quick. You don't actually save much time with add, subtract, or multiply, which is why you don't really hear of synthetic addition, synthetic subtraction, synthetic multiplication. However, the concepts are important, and it is the same concepts that move forward into synthetic division. Another reason why we don't use synthetic multiplication is because we have other little tricks that help us, like smiley face method or FOIL method, whatever you want to call it. Little tricks that help us to multiply a little bit faster when we're working with polynomials. So no one really uses synthetic math up to this point. But again, this is about conceptual understanding. I hope you join me again for part 2, which is synthetic division. And then if you want the real surprise, there'll be synthetic square roots in part 3, where you'll have a very interesting application to it. Thank you for watching. Catch you in the next video.